something completely different. Now, I have here a Van de Graaff generator. You've all played with those, I'm sure. It's one of the simplest devices ever made, if you understand it. All it is a hollow metal ball, and there's a rubber band that rolls on a track. Now that rubber band, as it goes around, carries charge. There's two other very important parts of this device. Down in the box, there's a metal comb with very sharp points. We're going to find next week that near a sharp point, we have very high, strong electric fields. Strong enough that we can actually take electrons and throw them across space onto this rubber band. Now the rubber band is an insulator or a conductor? An insulator. And that means when the rubber band, when the electron hits the rubber band, it's stuck where it hits. It can't move. It's stuck right there. And then the rubber band, as it's rolling around, brings it up into this metal ball. Up in the metal ball, there's a second metal comb with sharp points, creating electric fields that are strong enough to rip the electron off of the rubber band and put it onto the ball. Now once those electrons are put on the inside of the ball, they want to get apart from each other. So they move to the outside of the ball. And indeed, they find that they can get further away from each other if they move down this metal cord onto this metal plate. Now what that does is it charges this metal plate negatively. Too many electrons. Okay? Now I've got a chamber here. The chamber has a metal top and a metal bottom, but it's held apart. They're held apart by plexiglass, a non-conductor. Now, if I'm dumping a bunch of electrons onto this top plate, where are those electrons coming from? Do I have an electron generator in this box? No. I'm getting those electrons from the bottom plate. I'm dragging them off of the bottom plate through this ground wire here, and then they're shoved onto the rubber band, brought up here to the ball, and brought over here. So that means for every single electron that shows up here, I'm missing an electron down there. So this is going to get charged negatively. The bottom is going to get charged positively. Now, leave that alone for just a minute. What if in this room I were to paint the floor with positively charged paint? Everywhere in the room I paint with positively charged paint. What direction would the electric field in this room point due to that positive charge? Up, away from the positive charge. Now, what if I charged the ceiling negatively by painting it with negative paint? What direction would the electric field in the room point due to the charge on the ceiling? Up, towards a negative source. Now, if my floor is positive and my ceiling is negative, I have two fields. One due to the floor and one due to the ceiling, acting up. And that gives me a total field due to both up. Okay. Now, I'm charging up that chamber, negative on top, positive on bottom. That's the same if I just started painting the floor positive and the ceiling negative. Now I have here a metal ball. It's actually a ping pong ball that has been painted with metallic paint. And it's neutral. How do I know that it's neutral? Because it's being held by a fat man. Okay? The ball is a conductor. The fat man is a conductor. If there was excess charge on this ball, it would want to get away from each other. And the best way to do that would be to get on the great big man. Okay, so by holding this, I neutralize it. Now, if I take that neutral metal ball and I put it in this chamber, Now I'm going to turn off the Van de Graaff. Okay. What just happened?
Oh, that was cool.
My metal ball was neutral, and then it landed on this metal plate on the floor of my chamber that was positive. What charge did this acquire? Positive. And so now it's a positive charge in an electric field that points up. What direction is the force on a positive charge in a field that's up? Up. So it goes racing up and it hits the ceiling. When it hits the negative ceiling, it becomes negative. Now, what direction is the force on a negative charge in a field that is up?
Down.
Down. And so it's pushed down to the floor. When it hits the floor, it becomes positive. Now it feels a force up. It goes, hits the ceiling, becomes negative, and now it is pushed down. Up and down, up and down, up and down. It could go forever as long as I kept replenishing the charge on the plates. When I turned off the Van de Graaff, I stopped moving charge, electrons, from the bottom plate to the top plate. So now, it just had a fixed amount of charge. Now each time the ball goes up and down, it's carrying electrons from the top plate to the bottom plate. And if it keeps doing that over and over again, eventually it's going to neutralize both plates. And then it stops bouncing. Okay, then, see if your neighbor just understood that demo. See if they